Welcome everyone. Today we'll learn about subnetting, which is the process of dividing a large network into smaller subnetworks. Subnetting helps improve network performance, enhances security, and makes IP address management more efficient. It is one of the most important concepts in computer networking and is widely used in IPv4 environments. Subnetting is important because it reduces unnecessary broadcast traffic on a network. It also helps organizations use IP addresses more efficiently and organize their networks into manageable sections. By separating departments or devices into different subnets, network security and scalability can also be improved. An IPv4 address is made up of 32 bits and is typically written in dotted decimal format, like 192.168.1.10. Every IP address has two main parts, the network portion and the host portion. The subnet mask determines which part identifies the network and which identifies individual devices. A subnet mask helps identify the network portion of an IP address. For example, the subnet mask 255.255.255.0 is also written as /24 using CIDR notation. CIDR notation makes subnetting easier to understand and calculate. Let's look at a subnetting example. Suppose we have the network 192.168.1.0/24 and we need four smaller networks. To create four subnets, we borrow 2 bits from the host portion. This changes the subnet mask from /24 to /26. Each subnet will then contain 64 total addresses. Here are the four subnets created from the original /24 network. The first subnet is 192.168.1.0/26. The second is 192.168.1.64/26. The third is 192.168.1.128/26. And the fourth is 192.168.1.192/26. Each subnet has its own range of host addresses. To calculate the number of usable hosts in a subnet, we use the formula 2 raised to the power of h minus 2, where h is the number of host bits. In a /26 subnet, 6 host bits are remaining, so 2 to the 6th power equals 64 addresses, and after subtracting the network and broadcast addresses, we get 62 usable hosts. Variable length subnet masking, or VLSM, allows networks to use subnet masks of different sizes. This helps organizations allocate IP addresses more efficiently. Larger departments can receive bigger subnets, while smaller departments receive smaller ones, reducing wasted addresses. Some common subnetting mistakes include selecting the wrong subnet mask, creating overlapping subnets, and forgetting about network and broadcast addresses. These errors can lead to connectivity problems and inefficient network design. To summarize, subnetting improves network efficiency, organization, and scalability. Understanding subnet masks and CIDR notation is essential for networking professionals. The best way to master subnetting is through regular practice and real-world examples. This diagram shows how one larger network, 192.168.1.0/24, can be divided into four smaller /26 subnets. Each subnet becomes its own smaller network with a separate range of IP addresses. This visual demonstrates how subnetting helps organize networks more efficiently.